we conduct a jar test to evaluate the effectiveness of aluminum sulfate and ferric-based coagulant to reduce the turbidity, suspended solid, and improve the water quality to treat a raw water. The apparatus used in this experiment include a raw water sample, 6 beaker of 1000 ml, shrink, jar test apparatus, turbidity meter and spectrophotometer with sample cells, pH meter, and aluminum sulfate also ferric-based as coagulant.
Before starting the experiment, all apparatus were thoroughly cleaned using distilled water to prevent contamination and ensure accurate result.
Raw water sample was then poured into 6 1000 ml beakers with each beaker containing the same volume of the sample.
Next, approximately 45 to 50 ml of aluminum sulfate stock solution was prepared in a separate beaker for the dosing process.
Aluminum sulfate was added into each beaker using string at different dosage, which is 0, 3, 6, 9, 12, and 15 ml. Each beaker was clearly labelled according to its dosage to avoid error during analysis.
The water samples now treated with aluminum sulfate were placed into the jar test apparatus. The mixing pedals were lowered carefully into each beaker. Rapid mixing was carried out at 140 rpm for 3 minutes to ensure proper dispersion of the coagulant. The speed was then reduced to 70 rpm for 5 minutes to promote flock formation. Finally, the mixing was stopped at 0 rpm and the samples were allowed to settle for 15 minutes.
We measured the turbidity of the water samples using the turbidity meter. We took 10 ml of water from each sample, starting with the first sample with 0 ml of coagulant and placed it into 6 separate vials. Each vial was carefully wiped with tissue before being inserted into the turbidity meter. The signal average function was activated, followed by auto range mode. We then pressed the read key and allowed the reading to stabilize before recording the turbidity value. This process was repeated for all other samples, each with different coagulant dosages.
To measure suspended solids and color, we used the spectrophotometer. We took 10 ml of water from each straight sample and placed it into 6 separate square cells. The spectrophotometer was switched on and the stored program for measuring suspended solids was selected. A blank cell filled with distilled water was placed in the spectrophotometer to calibrate the instrument by pressing the 0 key. After calibration, the blank sample was removed and a sample cell filled with treated water was inserted. We pressed the read key and allowed the reading to stabilize before recording the suspended solids value. This process was repeated for all other samples to measure the suspended solids. The same procedure was followed to measure color by selecting the appropriate program on the spectrophotometer.
To measure the pH of the water samples, we used the pH meter. The pH electrode was rinsed with distilled water to avoid cross-contamination. The electrode was first placed in tap water to stabilize it. The electrode was then immersed in the treated water sample and the read key was pressed to obtain the pH reading. We waited for the reading to stabilize before recording the pH value. The step was repeated for all treated samples to ensure accurate pH measurement.
The same procedure was repeated for the ferric-based coagulant, following the same step for each test. After conducting the test, we analyzed the result. For turbidity, both coagulants showed effective reduction with each performing differently at various dosage as shown in the table. The suspended solid also decreased with both coagulants, with the table comparing their effect across the dosage. As conclusion, both alum and ferric-based coagulant were effective in improving water quality, where alum performed better in reducing turbidity and color, while ferric-based coagulant was more effective in reducing suspended solid at lower dosage. Both coagulants slightly lower the pH, but the water stay within safe limit. Overall, both coagulant meets the national water quality standard, but the choice depends on the specific water quality parameter being targeted.